Okay, now we come to magnetic properties of solids in today's session of class 12 chemistry. The topic that we are going to discuss is magnetic properties of solids. Now, what happens is that in a solid, if you apply a magnetic field, then depending on how the solid will react, accordingly it is classified as diamagnetic, paramagnetic, ferromagnetic, anti-ferromagnetic and ferrimagnetic. So there are these classifications. So what happens is that in a solid there are a large number of atoms and every atom has electrons. Now what happens is that an electron is a charge in motion. An electron not only spins on its axis but it also revolves around the nucleus. Now whenever there is a charge in motion, according to the laws of physics, it will produce an electric field. Any charge in motion or any current carrying conductor will produce a magnetic field. So basically whenever we speak of substances, we broadly classify them. The broad classification is diamagnetic, that means non-magnetic, and paramagnetic, that means they have some magnetism. Now fundamentally what is the difference between diamagnetic and paramagnetic? At a microscopic level, the diamagnetic, paramagnetic molecule, it will look like this. Okay, at a microscopic level, the paramagnetic substance will look like this, whereas the corresponding diagram for diamagnetic, it will be totally blank. That means in a paramagnetic substance, every atom will have some unpaired electrons, and the magnetism of those unpaired electrons will be the overall magnetism. So this is what you have in case of a paramagnetic substance, and in case of a diamagnetic substance there is no unpaired electron and therefore there is no magnetism at all. So you can see that this diagram is completely blank. The atoms do not have any associated magnetism. But in a paramagnetic substance, every atom has got an associated magnetism because every atom has unpaired electrons, and those unpaired electrons give a net magnetism to that substance. Now what we normally understand by magnetism is that there has to be a north pole and a south pole. That is compulsory. You cannot have magnetism unless you have both north and south pole. So I have drawn all these arrows. So each arrow, the arrow head is like the north pole and the other end is the south pole. So all these arrows together, they give us the magnetism associated with the paramagnetic substance. Now if you apply a magnetic field externally, suppose externally you apply a magnetic field to this particular material, then these magnetic dipoles, actually magnetic dipole is basically a combination of a north pole and a south pole. The best example of magnetic dipole is bar magnet. Another very good example of magnetic dipole is a compass needle. So there are so many other examples. So basically when you apply a magnetic field from outside, then the magnetic dipoles inside the paramagnetic substance, they will start aligning according to the externally applied magnetic field. So this magnetic field which you have applied from outside, the dipoles inside the magnet will start aligning according to that. That is what happens in a paramagnetic substance. Now in case of a diamagnetic substance, the magnetic dipoles inside the magnet will align themselves opposite to the external field. So the external field is pointing like this, and these will point opposite to the external field in a diamagnetic substance. Now that means a diamagnetic substance will repel any magnetism which is imposed on it. You can see that there were no magnetic dipoles, so some magnetic dipoles were induced and they were pointing opposite to the external field. That means a diamagnetic substance will repel any kind of magnetism which is imposed on it. A paramagnetic substance on the other hand will support any external magnetic field that is imposed on it. Now the difference between paramagnetic and ferromagnetic, that in a ferromagnetic substance it will strongly support any external magnetic field that is imposed on it. You can see that the magnetic dipoles are perfectly aligned after the imposition of the external magnetic field. And in an antiferromagnetic substance, what will happen? For every dipole which supports the field, there will be a dipole which does not support the field. So there will be an equal number of dipoles supporting and not supporting the field. And what about ferrimagnetic, FERRI, MAGNETIC, ferrimagnetic substances? There will be more number of dipoles supporting the field and less number of dipoles not supporting the field. So you can see that there are like 1, 2, 3, 4 dipoles pointing in the same direction as the field, but there are only 2 dipoles pointing opposite to the field. So in a ferrimagnetic substance, there will be more dipoles supporting the field and less dipoles against the field. So these are the 5 types of, broadly speaking, solids based on their magnetism: diamagnetism, paramagnetism, ferromagnetism, antiferromagnetism, and ferrimagnetism. So these are the 5. Okay, so regarding the examples of diamagnetic are H2O, NaCl, C6H6, H2O, NaCl, C6H6. These are the examples of diamagnetic. Paramagnetic is O2, Cu2 plus, Fe3 plus, and Cr3 plus. Then ferromagnetic is Fe, cobalt, nickel, gadolinium, and CrO2. Antiferromagnetic is MnO. Then ferrimagnetic is Fe3O4, Mg, Fe2O4, and Zn, Fe2O4. So these are all the descriptions and examples of the 5 types of magnetism displayed by solids. So that brings us to an end of this session, and your homework is you will have to say that out of these 5 types, diamagnetic, paramagnetic, ferromagnetic, antiferromagnetic, and ferrimagnetic, out of these 5 types, you will have to say that which one is very suitable for a temporary magnet and which one is very suitable for a permanent magnet. That will be your homework. Out of these 5 types of magnetism, which one is suitable for a temporary magnet and which one is suitable for permanent magnet. These are your 2 homework questions. and you can submit the homework by 9 p.m. Wednesday because there is no homework session today. So I'll end this meeting now. Bye all of you.